Hi, I'm HD, and we're going to discuss cocktail sort. So, cocktail sort is a sorting algorithm, and this is really a hybrid approach because it's based on another sorting algorithm called bubble sort. And the whole point of this talk is really to walk you through the whole process from start to end. Now, with cocktail sort, it's quite simple. You have 4 steps, and let's take a look. So picture that you have an array and this array is unsorted. That unsorted array we're going to refer to as the unsorted space. And the whole idea is to reduce that unsorted space as you sort left and right. So the first step is to bubble up the largest number from left to right. Once you've done that, you will then reduce the right unsorted space. And you're going to see what I mean in just a moment once we reach an example. Then once you have reduced the right unsorted space, you will then bubble down the smallest number, right? And then once you do that, you will then reduce the left unsorted space. Now these 4 different steps, you're going to repeat over and over again until your unsorted space is practically gone, right? So that's the idea. Let's look at this example. So say that we have this array of numbers, right? 5, 2, 4, 6, 1, 3, and our goal is to sort this. So the first step is to compare the 5 and 2, and then you want to ask yourself this question: is 5 larger than 2, right? Because the goal again is to bubble up the largest number. So is 5 larger than 2? Yes, the answer is yes. Because it's true, you'll then swap the 5 and 2, right? So we swapped it. Next, we're going to look at 5 and 4 and ask that same question. Is 5 greater than 4? Yes, it is. Because it is, we will then swap the 5 and 4, and that's what we have. So again, notice that what's happening here is that the largest number is bubbling up. So when you hear that concept bubbling, it's really taking the largest and then bubbling that up. Now, in just a moment, you'll see the same thing happening, but in the opposite direction. Right, so now we're comparing the 5 and the 6. So the question that we ask ourselves is 5 larger than 6? The answer is no, it's false. Because that's false, we just keep on going. Don't change, don't swap. Next, we have the 6 and 1. Is 6 larger than 1? The answer is yes. Therefore, we will swap. So swap the 6 and 1, and that's what we have. Moving along to the next comparison, we have 6 and 3. Is 6 larger than 3? The answer is yes. That is correct, and therefore we swap the 6 and 3, and this is what we have. So now that we've bubbled up the largest number, moving from left to right, the next step is to reduce the unsorted space on the right side, and that's what we do. So if you notice, we actually move the right wall from the right of the 6 to the left of the 6. So that means that this 6 is actually in its sorted position. We're not going to sort this 6 anymore. It's where it needs to be. It is the largest number in that array. So everything that we're going to do from this point on will be between those 2 right and left walls that we have. So now we need to do the next step, which is to bubble down the smallest number. So now we're going to be doing the opposite. Instead of bubbling up the largest, we're bubbling down the smallest. So now we're comparing the 3 and the 1. Notice that I'm moving from right to left. So we're comparing the 3 and 1. Is 3 smaller than 1? The answer is no. Because of that, we don't swap. We keep it exactly the same. Moving to the next pair of numbers. Is 1 less than 5? The answer is true, and therefore we do swap. So we have moved that 1 down a notch. Keep the process going. Is 1 less than 4? The answer is true, and therefore we will swap. Is 1 less than 2? The answer is true, and then we swap. All right, so notice that we now have the 1 there. The next step in the process is to move the left wall So we are essentially reducing the left unsorted space. Now, if you notice, the unsorted space is getting smaller. And that's the whole idea here, is that as you go back and forth, you are reducing the space that is unsorted. So now this means that the 1 on the far left is in its sorted position. It's not going to change. And in a similar fashion, the 6 on the far right is also in its sorted space. So now we're going to be looking at all these numbers between the left and right wall. So we're going to start the process over again, and we're going to bubble up the largest number. So we're looking at the 2 and 4. Is 2 larger than 4? That is not true. Therefore, we don't do anything. Is 4 larger than 5? The answer is no, and therefore we don't do anything. Is 5 larger than 3? The answer is yes, and therefore we swap. Therefore, the 5 has been bubbled up. And now we're going to be reducing the right unsorted space by a notch. And this is what we have. So now we only have the 2, the 4, and the 3. And we're going to bubble down the smallest number in our unsorted space. Let's compare the 3 and the 4. Is 3 less than 4? That is true, and therefore we swap. Is 3 less than 2? The answer is no, and therefore we don't swap. Keep it exactly the same. Now that we've done that, we will then move the left wall up 1 notch. We are reducing the left unsorted space. So now all we have is really the 3 and the 4, right? So let's keep this going. Now, by the way, if you pass this point, what you'll see is that at some point you don't need to continue the algorithm. You can actually stop. But for the sake of just kind of showing you how this works, I'm going to keep on going. And I'll keep on going until our unsorted space is completely empty. All right, so now we're going to bubble up the largest number. So let's compare the 3 and the 4. Is 3 larger than 4? The answer is false, and therefore we don't swap. And now we're going to reduce the right unsorted space. By the way, if I stopped here, you would see that we actually have everything which is sorted. But again, I want to emphasize the method that we're using and keep on going until we have nothing left. Now we have this, and then we will reduce the left unsorted space. And then as you see, we have our unsorted space, which is completely empty. So once we've done that, we've sorted this completely. And that's it. So kind of looking at the big picture again, cocktail sort is really bubble sort, but you're doing that in both directions, and you're also reducing the unsorted space. And for sure, you can definitely do various approaches of optimizing this. For example, one of the optimizations is what I mentioned before. If you have an unsorted space, which is just 2 elements, and then you run through that, you can stop. You don't have to keep on going. So hopefully you guys have seen how this works. And if you have any questions, please let me know below. Thank you very much. Bye.